Okay then, guys, let's have a go at 28 then. We've got a fractional thing here. We've got 4x squared plus 3x minus 5 on top divided by x cubed. It's akin to something that looks like this. 3 plus 4 plus 5, say over 7, say. If we had that, it would be 3 over 7, 3 sevenths, plus 4 sevenths, and plus 5 sevenths, wouldn't it? Because you just read it, it says 3 plus 4 plus 5 sevenths would be 3 sevenths plus 4 sevenths plus 5 sevenths. There we are. So we adopt the same process here with this more complicated looking expression here. So we'll have then, let's split it up then using that rule or principle. So it's the first 3 plus 4 plus 5 sevenths would be the 3 over 7 is the first term of what's underneath. So the first term over what's underneath, there we are, 4x squared over x cubed, plus the second term over what's underneath, yeah, plus the third term, which is minus 5 over what's underneath. There we go. So we've split the fraction up. Now we need to use a couple of other rules for indices. X to the a over x to the b, divide you minus top take bottom. So there's the rule there. And we're also going to need to use x minus a. When you want to bring something up to the top, or take it down below, so to speak, you flip the sign of the index. So I'll just put that rule there as well. So with these two rules in mind then, let's work out the next line. 4 lots of, divide you minus top take bottom, yeah? So 2 minus 3, x to the power is minus 1. This is power 1, of course, so let's put that in explicitly. 3 lots of x, divide you minus top take bottom, 1 take 3 is minus 2. Next one, minus 5 lots of, I'm going to flip this up to be by the 5, and we flip the index from plus to minus. It flips, doesn't it? Sign. So 3 goes to minus 3. There we are, everything's on ground level now, so we can do the differentiation. So let's do that. We get minus 1 times 4 is minus 4. X to the 1 less is minus 2. Minus 2 comes down to be with the plus 3. Plus the minus is a minus. 2 3s is 6. X to the 1 less than minus 2 is minus 3. The minus times a minus is plus. 5 3s are 15. X to the 1 less than minus 3 is minus 4. There we go. Now I'm going to bring everything down below to make it easier on the eye. After I've done the differentiation, there was the differentiation. So we end up with minus 4. Drop that down, you get x squared because you flip the minus 2 to 2. Then you get minus 6. Drop the x to the minus 3 down and you flip the minus 3 to 3. Plus 15 and drop the x to the minus 4 down and you can write just flip the minus 4 to 4. There we go. Now input the value then at x equals minus 1. Do y dx equals then, we've got minus 4 over x squared minus 6 over x cubed plus 15 over x to the 4. And now we're going to substitute in the value minus 1, aren't we? So wherever we see an x, put a little bracket around it and put in overwrite minus 1. Little bracket, overwrite minus 1. Oops, a bit messy there. And little bracket around it, overwrite that with minus 1. There we go. That'll do. So what have we got? We've got y dx then equals minus 1 squared is 1, minus over a plus is a minus, 4 over 1 is 4, minus 1 cubed is a minus, minus over a minus is a plus 6 over 1, which is 6. Minus 1 to the 4 is a plus, isn't it? 4 minuses make a plus. 15 over 1 is 15, so we've got plus 15. 15 plus 6 minus 4. 21 take 4 is 17. There we go. It's the answer to 28. 28. That's it. So you'll notice here, right, that we spent an awful lot of time tidying the thing up. So we had to split the thing up using fractions, which we use this sort of property here. Once we'd split up into fractions, we had to invoke the rules for indices, which was either this one or this rule for indices here to get everything on the ground level. So everything was nice and easy then to differentiate. Then we differentiated. This is the differentiation line. So do y dx, then you differentiate term by term running along the row. Then I tidied it up, so we tidied it up there to make it look easier on the eye. And now we've got the derivative, dy dx. We can input the value x equals minus 1 and simply write out the same line as above and overwrite wherever you see an x the value we want to input. So I put a little bracket around it as well. so to avoid any confusion. Then just work it out and calculate it and you get the answer. Okay, that's basically the general process. Tidy, differentiate, tidy and evaluate. That's it. Job done. Let's move on to 29.